Okay, pre-calculus. We're still on our Chapter 3, Semester 2 review. We're still on Lesson 3.1 with exponential growth and decay functions. This was our calculator and word problem day. So we can see that number 6 is a compound interest problem. So on your formula sheet, you'll have this formula, A equals P times 1 plus R over N raised to the NT. So let's jump in and see what we know and what we're going to find. So we don't know the amount he's going to have in the future. The principal P is $5,000. 1 plus 2.9%, move the decimal 2 places. Monthly is 12 compoundings per year, and so that's 12 times the number of years, 4 years. So go straight to your calculator, type that in, and we're going to go dollars and cents. You should get $5,614.19. All right, also on your semester exam formula sheet, we do have some problems that we can use with just general exponential growth and decay situations. So the formula from your formula sheet says the number of whatever you have would be the initial value, 1 plus or minus, depending if it's growth or decay, then the percent of growth or decay, and then T is usually measured in years, but it could also be a time in weeks or days, depending on the problem. So coronavirus, oh, that's a fitting problem. Wow. All right, so its population is decreasing at 1.2% per week. Initial population of 10,000. What will happen 6 weeks later? So let's take a look. 10,000 people. 1 minus 0.012. And it's 6 weeks. So go ahead and type that in to the calculator, and the population will be about 9,301. All right, same exact problem, but this one's different because now we want to figure out how many weeks. So that is the T value that we're going to be solving for. So let's say the population got down to 9,000. I know it's a little bit depressing. Starting from 10,000, 1 minus 0.012 to the T. And when we do this problem on the calculator, we are going to go ahead and use the variable x. So what's going to happen here? Now you might use, so that we did this problem in lesson 3.1, but and we use the calculator. You could also solve it using algebra from lesson 3.4. So you might think that's even faster. You can do that. I'm going to go with the calculator for this one. There's y1. There's y2, and so we're going to find that point of intersection. Let's see if we can get this to work. Okay, that was the last problem that we did. All right, so 10,000, 1 minus 0.012 raised to the x. Okay, we have a problem. All right, something's not right. We'll try again. 10,000, 1 minus 0.012 raised to the x. I think we're okay. And we want the population to be 9,000. Now normally I always start with zoom 6. And that looks fantastic, except it doesn't help us with the problem. So we do have to know a little bit of our graphing knowledge. We do know that the y-intercept is going to be at 10,000. So our initial population was 10,000. So my y max, I'm going to go a little bit bigger just because I like to see where that crosses. Now we don't know how many years this is going to take, how many weeks. So I might start with not changing anything else and just press graph, and let's see. So there goes the population, and there goes the answer of 9,000. So it looks like they're crossing on this window. So second calc 5 for the intersection, enter, 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 and that's awesome. So we'll call that approximately 8.727 weeks. All right, we'll pause this video and we'll pick it up where we left off with the next one. Thanks for watching. Bye-bye.